Hey, physics. Something a little different today, right? You should see a lab like in the assignments over on my CBA, and it tells you to go to a website, right? phet.colorado.edu. You can see it kind of way in the bottom left there. It'll take you to this page. You go to the simulations, go to the physics simulations. There are many of them, right? There are simulations for all different classes, different grade levels, that kind of thing. Yeah, there were some chemistry ones that maybe we would have done last year. Anyway, um, right. Static electricity, there's bending light, there's charges and fields, but the one that I'm worried about is right here, Circuit Construction Kit DC Virtual Lab, right? So if I'm going to click on that, this runs in HTML5, which basically just means it runs on the internet, right? Um, I realize that my face is covering something up here in the top right, so what if I just... Yeah, okay. This button down here in the bottom will just reset the screen, but I'll just cover that up for a second. Alright, so up that way, right, there are the components to a circuit. There are lots of components. You can play with this kind of as much as you want, experiment with it, see what happens when you connect pieces, right? Above me are ways to show the current. You should show the current, have labels. I'm not really bothered about the values, but there's also a voltmeter and an ammeter. You should remember those from our, our discussions during class or during these videos. There's also a little thing here that's the wire resistivity and the battery resistance. Don't worry about these. The advanced options are not things that we're going to delve into. What I want y'all to do is follow the directions that are in there. The first circuit is one that you need to make with a 15-volt battery, several resistors, and you're supposed to connect them in parallel. All right. I will quickly demonstrate how to make a simple series and a simple parallel circuit. I'll make the ones that I made originally. So they had a battery, right? I can attach a wire. You can click and drag, manipulate the wire. If you don't want these to be connected anymore, it's all regular clicks, all left clicks. So if I click here and I disconnect, they will disconnect. If I attach them, they will attach again. So here I am. I am going to make the series circuit that had... Oh, I think when I oriented it, I think I had it this way, right? So I did it this way. There was a battery that had a wire, right, connected to a wire, connected to a resistor. Ooh, come on, bend. There we go. And then wires going back down, right? Now it looks like I'm putting a few excess wires in here. I'm doing it because it'll show my point. And there. Now we have charge flowing. I've completed the circuit, right? While this was incomplete, it would not finish, but once it's there, everything will move, right? I want you to notice. Look, that's the drawing I made. Here's a battery. Oh, they do it kind of bad. This is annoying. They don't do the battery with 4 lines. They only do the battery with 2 lines. But there's a battery. There's a resistor, and there are some wires, right? If I don't show the current, that's the picture I drew, all right? Anyway, so we'll go back to the actual conventional stuff. So here is this, right? Also, you should notice wire, battery. The light bulb is a little different. Resistor, a switch, the regular wire. Again, it's just they show you different things. But so there is a series circuit. I think I made a slightly more complex one. The nice thing is all of this is just modular, so I can move each piece like this. I think I made a different one where I had 2 resistors, and if I put 2 resistors in series, boom. Now everything moves slower, which is what you'd expect, right? Adding resistors in series makes things go slower. And again, if I switch over, right? That's the picture I drew of 2 resistors connected in series. If I wanted to connect these in parallel, I would need to do this. If you want to get rid of a component entirely, you can just hit that button. So there's that wire, right? I will also have to connect these pieces, and then I'll connect these. And I'll connect this. And look, everything got faster. I want you to notice that, right? Look at the speed. Look at the speed now. And then compare that to here. Everything does move a little faster, right? And that should make sense. More pathways means less overall resistance, right? So what you're going to have to do is follow the directions to see how to connect them, right? If you want to adjust the voltage, you can adjust it here. So I think one of them called for 15 volts. All right, notice they go faster. This should be 15 ohms. I want you to notice what happens if I make them different resistances. This one is bigger, this one is smaller. More charges take the path of least resistance, even though it's further away, right? Also, I do want you to notice the colors do change. There is a language to the colors on a resistor that we don't need to worry about. If you take more physics eventually, if you take more engineering eventually, you might talk about it, but the colors do actually mean something. But there is a parallel circuit with two resistors. Follow those directions, right? Add in a voltmeter as needed and take a voltage. Add in an ammeter as needed. You should notice that you don't have an opportunity to connect the voltmeter in series. You have to connect the ammeter in series. That should remind you of something, all right? But add those kind of as you need them, all right? You'll submit that online if you want to do that like a Google Doc. Google Doc is probably like the easiest way to type out those answers and insert the pictures. Then you can just upload one thing. If you do it in multiple files, you have the ability to do that, all right? But I just wanted to show you this simulation. Obviously, this, again, is not the only simulation on there. There are lots of them. From the energy, there's some stuff here with forces and motion. There's some stuff with how friction works. There are simulations for projectile motion. There's simulations for lots of things, right? We'll eventually talk about waves, but again, that's a soon to later. The lab was Circuit Construction Kit, DC, Virtual Lab, and we'll talk more about that on Friday. Now, do your best to get that into me by Friday. If you can't get it to me by Friday, please get it to me by like Sunday or Monday, just because I want to put it on this marking period, all right? If you have questions, email me. Otherwise, until the next class or the next video, I'll see you. Take care of yourselves, kids.